Hello, in this video, we have addition and subtraction of rational expression. In the first part of the video, we'll be looking at adding and subtracting rational expressions with the same common denominator. And later in the video, we'll be looking at adding and subtraction rational expressions with different denominators. Now, if you add two expressions that have the same denominator, and a basic example will be a fraction. If I say add 4 over 9 plus 2 over 9. So here, this have the same common denominators. Okay, the denominators are the same. Anytime you add or subtract rational expression, the denominators must be the same. Okay, so it is very important to add or subtract rational expressions the denominators must be the same. So when the denominators are the same, what we do, we keep the denominator. Okay? We will keep the denominator. We do not add the denominators. So here the denominator is 9, so our denominator will be 9. And what we then do is add the numerator, 4 plus 2. So this becomes 6 over 9. And we always check to see if we can simplify. If we can simplify. Okay? So if you notice 6 over 9, we can divide here by 3, and we can divide here by 3. And that would leave us with 2 over 3. And that's my simplified answer. That's my simplified answer. So the whole idea is that once we have the same denominator, okay, then we just add or subtract. Now, if we look at a different example, if I say to add, and I have x divided by x squared minus 1 plus 1 over x squared minus 1. So notice my denominator here and my denominator here are the same. So we already have same denominators. If the denominators are the same, what we do, we keep the denominator. So we have x over x squared minus 1 plus 1 over x squared minus 1. So we'll keep the denominator, okay, which will be x squared minus 1. And then the numerator, we add 1 plus x. Now we can't add 1 on x, so that stays as the same, okay? So we have x plus 1 over x squared minus 1, but we want to check for simplification. So if we do this, you will notice that this denominator here is a difference of squares. So we have x plus 1 divided by x minus 1 times x plus 1. And then you will see that this will cancel with that. And keep in mind, okay, since the x plus 1 here is in the denominator, it stays in the denominator. And when things cancel, that numerator has a 1. Okay? So this is my simplified answer. That's my simplified answer. Now, in addition, okay, we tend to just add items. But how about if I say subtract 2x minus 5 over x minus 2 minus x minus 3 over x minus 2. So once again here, we saw that we have same common denominator, right? The common denominator is x minus 2. It's the same. So all we do is that we keep the common denominator, okay? And then we just subtract 2x minus 5 minus x minus 3. I keep them in parentheses this time because when you distribute now this negative, as you get rid of the parentheses, we're going to have two x minus 5 minus x plus 3 over x minus 2. So you have to be a little bit careful. Be careful, right? With subtraction. Just be careful because you're going to have to distribute. Now, combining like terms, okay, combine like terms. Remember, the denominator does not change. So if we combine 2x minus x, that will leave you with x. And then we have a minus 5 plus 3. That will leave you with negative 2. And since we have, check for simplification, you will notice we have x minus 2 over x minus 2. So the denominator is the same as the numerator. So we can say that this will cancel with that. And we say cancel, but anything divided by itself is 1. So the answer here turns out to be 1. If we look at one more example, Yeah. Last one we did was subtract, so let's do one more. Subtract. And let's say we have 7x minus 1 over 3x plus 2 minus 4x minus 3 over 3x plus 2. So once again, notice my denominators are the same. So the common denominator is 3x plus 2, right? So if they have the common denominator, we already just write 3x plus 2. And then we just add or subtract whatever that sign is here. So this will be 7x minus 1 minus 4x minus 3. Now we keep the denominator as we've been doing, 3x plus 2, and then we have 7x minus 1. But as you distribute this negative sign, okay, this becomes minus 4x plus 3. And then we combine like terms, so the denominator is still 3x plus 2. If we combine like terms, 7x minus 4x, that becomes 3x. And we also have minus 1 plus 3, which becomes plus 2. So this is just a coincidence, right, that the denominator and the numerator have become the same. This will not always happen. So now we simplify, and it's not going to always simplify too. So we have 3x plus 2 over 3x plus 2, and anything divided by itself, we know, is 1. So the final answer again happens to be 1. Just a coincidence. Okay? It's not going to always be 1. Now let's look at cases where the denominators are not the same. Okay? What happens when the denominators are not the same? So now we'll look at addition and subtraction with different denominators. And before we look at any example of addition of fractions with different denominator, we need to review, okay, review what is least common denominator. Okay, and the abbreviation is LCD. Yeah. Now the least common denominator for a set of denominators is the smallest expression that is divisible by each of the denominator. Yeah, the smallest expression. So in addition and subtraction of rational expressions, it would be nice if you find least common denominator. But if you don't, then it's okay. You can just find a common denominator. It just means at the end of the problem, you will have to simplify this. So let's look at an example, okay, that involves fraction. Because I don't want to really worry too much about least common denominator. For our case, we can find what is called a common denominator. It's okay if you find least common denominator. We can just find common denominator. Okay. So why am I telling you this? For example, if we have the two fractions, okay, and I say add 2/3 plus 3/4. Now the traditional way is to find least common denominator, right? Which will be 12 in this case. Well, I don't really care so much for least common denominator is what I'm saying. What we can do is ignore this, okay? And we can write the least common denominator or the common denominator as 3 times 4, okay? And once I do that, we take the 2 from the numerator and we multiply it by some number, and that number would be, look at what I'm doing, notice that you have a 3 in this denominator here. Let's use a different color, 3 here, but in this new denominator you have a 3 and a 4. So you have an additional number 4 in the bottom, so you will have to multiply the top by 4. Yeah. Plus, I'm going to take the 3, I'm going to take this 3, and I have to multiply that by something. Well, let's do it again. Look at this denominator here. Yeah. Look at this denominator here. It's a 4. But over here you have a 4 and a 3. So what you're going to do is multiply the top also by 3. Now, what some people tend to say is you can think of this as if you cross multiply. So this part becomes 2 times 4. But you can't say cross multiply because you can only do cross multiplication when there's an equal sign, right? But you can think about it that way, 3 times 3. So if we continue to do this, okay, my next step, 3 times 4 stays, and in the numerator, 2 times 4 is 8, plus 3 times 3 is 9. Now since I'm only dealing with fraction, 9 and 8 is 17, and if you want to multiply the bottom out, 3 times 4 is 12. And remember, check for simplification. In this example, there is nothing to simplify. And since it's an algebra class, we can leave it as an improper fraction. Okay? We can leave that as an improper fraction. Now, let's look at a rational expression now, polynomials, where we don't have the same denominator. Okay? So, example, how about if we subtract and we have 3x plus 1 over 2x minus 6 minus x plus 2 over x minus 3. So here's the first thing I'll do. Step 1, okay. We notice that different denominators, okay, denominators are different. So if the denominators are different, step 1, factor each denominator. Yeah? So if we factor each denominator, this becomes 2 parentheses x minus 3. 3x plus 1 stays in the top. Minus, there's nothing to factor in x minus 3, so it stays. So now my common denominator is 2 times x minus 3. Okay? Pay attention. Notice I already have it's 2 times x minus 3, which I'm getting from here. But notice this here is also x minus 3. So there is no need to write x minus 3 again because it will be repeated. So it is really 2 just times x minus 3. That's my common denominator. And realistically, what you've just done there is the lowest common denominator. Okay? So do not write it if it's repeated. Okay? We only write it once. So if I'm adding these two things, okay, 3x plus 1 over 2 times x minus 3, subtract them, I said add. If I'm subtracting these two fractions, then in the denominator now, I have 2 parentheses x minus 3. Okay. Now, we do a comparison. Notice that this is the same as this. So we don't have to multiply the top by anything, or we can say we're multiplying it by 1. Yeah. Minus, okay, let's compare the next denominator. If you look at this denominator, we have x minus 3. If you compare it with the common denominator, we have 2 times x minus 3. So I'm really multiplying the top and bottom by some factor of 2. Okay? So this becomes 2, okay, times x plus 2. So distributing that negative sign, we have 3x plus 1 minus 2 times x, and minus 2 times positive 2 becomes minus 2x minus 4. All of that over the denominator, 2 times x minus 3. And I don't multiply the denominators out, because later on, if you have to simplify, you will see the cancellation easily. So 2 times x minus 3. Now if we combine like terms in the numerator, 3x minus 2x becomes x. And then we have plus 1 minus 4 becomes minus 3. And remember, you should always check, okay, for simplification. So you'll notice that we have x minus 3 over 2 times x minus 3. So this x minus 3 and that x minus 3 can be divided. And remember, your 2 is in the denominator, so it stays in the denominator. And then a 1 stays in the numerator. Okay? So our simplified answer is 1 over 2. Let's look at another example. If we have add x plus 7 over 2x plus 12 plus 6 over x squared minus 6. So notice denominators are different, okay? Different denominators. So step 1, factor each denominator. If we do this, we'll have 2 parentheses x plus 6. The numerator stays the same. And the second denominator, x squared minus 6, let's change this here. Make it x squared minus 36. Okay. So now we can factor that denominator as x minus 6 times x plus 6, because it's difference of squares, right? X squared minus 6 squared. And the numerator stays the same as 6. So now, what is my common denominator? Common denominator, I start out with the first and I write everything. There's a 2, there's an x plus 6. Then I move to the next denominator. There's an x minus 6. And then if you look, there's an x plus 6, but I already have x plus 6 there. So I don't need to write it twice. Yeah? We don't need to write it twice. Right? So we only write it once. Or you can write everything out and take out repeated. Right? Notice that if you write 2 parentheses x plus 6 times the x minus 6 times the x plus 6, any repeated, you only write it once. Okay? Once it's repeated, you only write it once. So either this way or this way. Regardless, the common denominator is 2 parentheses x plus 6 times x minus 6. So if we look at this, we have x plus 7 over, when we factored, we had 2 parentheses x plus 6 plus 6 over x, which one, minus 6 times x plus 6. And we're saying that the common denominator is now, 2 parentheses x plus 6 and then x minus 6. Okay? So we take the numerator, which is x plus 7, and then we compare the denominator. Here we have 2 parentheses x minus 6. If you look here, we have 2 parentheses x minus 6, but we're multiplying it by x minus 6 also. So I have to multiply the top here, top and bottom, by x minus 6. So we have an x minus 6 here. And then I do the same thing, okay? So we have plus, and then I look at the other. In the next denominator, I have x minus 6, x plus 6. So here we do have an x minus 6 and an x plus 6, but I have an additional 2 there. So I'm going to multiply the top and bottom by 2. So this becomes the new 6, and then in parentheses times 2. Okay. So we have 2 times x plus 6 times x minus 6 And then if I multiply out these two terms, we have x squared minus 6x plus 7x minus 42, okay? Plus 6 times 2 is 12. Combine like terms in the parentheses. We have x squared plus x minus 42 plus 12. The denominator always stays the same. And we do not multiply out the denominator because at the end, if there's any simplification, it's already in factored form. So notice that I combine the like terms over here to get this, okay? But I also have like terms here. So if I combine those, we have x squared, okay? Squared plus x. And if you combine the minus 42 and the plus 12, we have minus 30 over 2 parentheses x plus 6 times x minus 6. Now at this point, you have to check, simplify. Okay? So as you can see, this is quadratic. Yeah. So this could possibly be factored. That can possibly factored. And if you factor that, you get x plus 6 times x minus 5 over 2 parentheses x plus 6 times x minus 6. And now you look to see, can we cancel anything with that from the numerator and the denominator? You will notice that the x plus 6 will cancel with the x plus 6. So what do you have left in the numerator? X minus 5. And in the denominator, you have 2 parentheses x minus 6. You can multiply this out if you want, but it doesn't matter. So you could leave it the way it is. X minus 5 over 2 times x minus 6. I generally tell students don't multiply it out. Or you can write x minus 5 over 2x minus 12. Either one of these is correct. I think this is enough, but it all depends on who is your professor or your teacher and who is looking for what specific answer, if any. Another example. Subtract. What if we have 2x minus 2 over x squared plus 4x plus 3, subtract x minus 1 over x squared plus 5x plus 6. So observe that the denominators are different, right? We have different denominators. We'll start step 1, factor each denominator. Okay. If we do that, we have 2x minus 2 over, okay, x plus 3 times x plus 1 minus, if we factor the second denominator, we have x plus 3 times x plus 2. Now, since we have to factor denominators, we can find our common denominator. So we always start off by writing x plus 3. Then we move to the next one, x plus 1. There's nothing else there, so we move to the next one, x plus 3. But notice we have x plus 3, so there is no need to write it again. And then we have an x plus 2. So since these two are repeated, we only write it right once. Right once. So we have x plus 3 times x plus 1 times x plus 2. Okay? We don't need to write it twice. So our common denominator is x plus 3, okay, times x plus 1 times x plus 2. Now, if we look at this term here, okay, if we look at this denominator and compare it with this denominator, you will notice we have an x plus 2 there. Okay? So I'm multiplying the bottom by x plus 2, so I must multiply the top by x plus 2 also. Okay? Once again, in this denominator we have x plus 3, we have x plus 3. Then we have an x plus 1, we have an x plus 1. But the new fraction, the denominator, has an x plus 2. So we multiply the x plus 2. If we do it in the bottom, we have to do it in the top. So this becomes 2x minus 2 times x plus 2. Minus, I do the same thing for the next fraction. We have an x plus 3. So we have an x plus 3 here. We have an x plus 2. We have an x plus 2 here. We don't have an x plus 1. So I'm going to multiply the bottom here by x plus 1. Therefore, I must multiply the top also by x plus 1. So this fraction, this numerator, becomes x minus 1 times x plus 1. Okay? If we multiply out the numerator, so the denominator stays. If you multiply this out, you will get 2x squared, okay, I'm falling out, plus 4x minus 2x minus 4. Minus, which is this minus here, if you multiply this out, you will get x squared plus x minus 1. We're going to now combine like terms. Okay. Denominator stays the same. So we have 2x squared plus 2x minus 4 minus, combine like terms here, plus x and minus x goes away. So we have x squared minus 1. And you should have seen that because this is difference of squares here, right? This here is difference of squares. So when you multiply it out, you know, you would have get x squared minus 1. Now, we can simplify more by getting rid of the parentheses, so the denominator stays the same. And we need to write it. I know it's long, but you need to write it out. So we have 2x squared plus 2x minus 4. And now when you distribute this negative sign, okay, you end up with minus x squared plus 1. And then we combine like terms again. Denominator is still the same. So if we combine 2x squared minus x squared, that becomes x squared. Okay, and there is no other term but the 2x, so we bring down the 2x. And if you look, we have a minus 4 and a plus 1, so that becomes minus 3. And now we check, okay, simplification. So the numerator is quadratic, so that can be factored. Okay, so the denominator stays the same. But if you factor that numerator, you will get x plus 3 times x minus 1. And now we look for same items that can be cancelled. So notice that the x plus 3 and an x plus 3 here. So finally we have x plus 1 times x plus 2. And in the numerator we have an x minus 1 left. Okay? So this is our simplified answer. So my last example, how about if I say subtract, yeah, 2 minus 9 over 3x plus 1. Now, if you look at this, it kind of looks different from what we're doing. But if you make a slight change, okay, you can rewrite 2 as a fraction. So as a fraction, 2 is 2 over 1. So I can write this as 2 over 1 minus 9 over 3x plus 1. And now notice my denominators are different. Okay, different denominators. Different denominators. So step 1, factor each denominator. Well, if I do that, I will still have, okay, 2 over 1 minus 1 over, there is nothing to factor, 3x plus 1. So there was nothing to factor. So my common denominator, we'll start off with this one, is 1, and then this one here, 3x plus 1. And that's it. Nothing is repeated. So my common denominator is 1 times 3x plus 1. And then I compare. So notice here I have a 1. I have the 1 here. But there's also a 3x plus 1. So it means that I'm multiplying the bottom by 3x plus 1. So I must also multiply my top. So this here becomes 2, and then times 3x plus 1. Minus this minus. If I compare my second denominator, I have a 3x plus 1. So I do have a 3x plus 1 here, but I have a 1 here also. So I multiply the top and bottom by 1. So the top here becomes 1, but then times 1. Okay. Distributing here, so we have 2 times 3x is 6x, plus 2 times 1 is 2, and then minus 1 times 1 is just minus 1 over 1 times 3x plus 1. Combining like terms, we have 6x plus 1 over 1 times 3x plus 1. And then don't forget to check for simplification. Sometimes you may. So we cannot factor anything from 6x plus 1. Okay? We can't factor that. Just notice that the original problem, this is a 9. So we need to make that little change there. This will be a 9. This will be a 9. So we can actually factor something from the numerator. We can factor out a 3, and that will leave with 2x plus 3. If that's a 9, sorry, then we have like term 2x minus 9 becomes minus 7, right? Not just a 9, because we do have like terms now. So there is nothing to factor in the numerator. So 6x minus 7. And in the denominator, we don't need to write that 1 there. 3x plus 1. So this is my simplified answer. So as you can see, the errors I made, right? We have to be very careful, right? And write the numbers. Since there's a lot of repeated writing, it's easy to make a mistake. We just have to be careful. So no matter what the problem looks like, right? If the denominators are the same, you just add the numerators or subtract them. When they're not, then we have to factor the denominator, find the common denominator, and then work our way through the problem. As always, you should practice more examples on your own. The more examples you do, the better you become. And see you next time.